Here we go. Representing rational functions is a power series. We're going to call this level 2. Here we go. So this one's a little bit more complicated. We have to take this rational function and get it to look like this one so that we're able to substitute and turn it into a power series like so. So I changed this letter to an M just because when I have a bunch of X's everywhere, it makes me a little bit confused, especially in this trickier case. So I just changed the letter so that we can see things a little bit clearer. So first things first, I need to get a 1 in the numerator, so we have to change this 3. Well, the way that we're going to do that is by taking out 3, right? Reverse distribute. So we take out this 3. Left hand side, we got 1 over 4 plus 5x squared. All right, next step, I have to attack this piece of our rational function, and I need to get that piece, right, to be a 1. So the only way to get a 4 to be a 1 is, well, I have to take out a 4. But we're taking out a 4 from the denominator, so this is going to become 3 over 4 times 1 over 1 plus, well, 5. You have to divide that by 4 as well because, right, when we distribute, we go to both terms in a binomial. So we have 5 over 4 x squared. All right, one more issue is I need a subtraction sign right there. We have an addition, so I'm going to rewrite this one more time, and I'm going to write it as 3 over 4 times 1 over 1 minus negative 5 over 4x squared. Now at this point, I'm just going to be like, yo, you know this piece right here? Yeah, that's going to be m. That's what I'm going to plug in right there. So let's do that. That means that this rational function, h of x, is equal to the power series, the sum from n equals 0 to infinity of, well, have to include the constant here, 3 over 4 times negative 5 over 4 x squared to the n. All right, there is a prettier way to write this. I like to distribute the n through. So this is going to become 3/4. This n exponent gets put on every single piece inside there because it's all multiplication and division. So times negative 5 to the n over 4 to the n times x to the 2n. All right, just one more time. Since this is 4 to the first power, and that's 4 to the n, when we multiply and we have the same base, we add the exponents. So the sum of n equals 0 to infinity, 3 times negative 5 to the n divided by 4 to the n plus 1, and then times x to the 2n. That's how I would write it. And then we need to worry about interval of convergence, right? The only way that we can find the sum of an infinite series is if the sequence converges. And that only happens if we approach one singular number. So if m right here is a big number, let's say it's 5, well, 5 to the 100th, 5 to the 1000th, right, keeps getting bigger and bigger, well, that would shoot off to infinity, so that we can't use that one. But if this number here is a decimal, well, then it's going to keep getting smaller and smaller and approach 0. So it's important to remember that our interval of convergence is when x, I'm using m, is less than 1. So Rm here is that piece. So our interval of convergence is going to be the absolute value of negative 5 over 4 x squared is less than 1. Then solve and get x by itself. So we're going to divide by negative 5 over 4. Well, when we divide by a negative, our sign's going to flip, remember? So we've got the absolute value. Well, actually, if we have a negative in there, does negative inside the absolute value, does that matter? No. Right, so it just turns into the positive version anyway. So we're going to divide by 5/4, which is the same thing as multiplying by a reciprocal. So we got the absolute value of x squared is less than 4/5. Then we have to take the square root of both sides, and we don't need the plus or minus because the absolute value takes care of that for us. So we got the absolute value of x is less than the square root of 4 over the square root of 5, making sure we rationalize. So that means our interval of convergence is the absolute value of x is less than 2 root 5 over 5. Right? Got that 2 because the square root of 4 is 2. So interval of convergence, power series.